Look around you. Where are you? Where is this place you are occupying? Somewhere in a room, maybe? In a city on a continent? On a planet orbiting a star? In a galaxy among billions? But where is all of that? While this may feel like a daft question, it turns out that the concept of an absolute position is something humans made up. In a nutshell, the universe is a big bag of space that has things in it. If someone removed all these things, the stars, the planets, and the black holes and dust, there would just be empty space left. An empty space. The concept of having a position loses all meaning. Empty space is uniform, the same everywhere. The space we occupied is not like a stage under our feet.
We can't mark specific points or staple something to space-time as an anchor. Without things, there is no position. We are really ever only at a position in relation to something else. Which also means that things we take for granted like up and down are actually relative too. Okay, let's fill the universe up with things again and try to find out where you are right now relative to everything else. Let's start this video at a familiar place and then get increasingly wet. From your perspective, the world is seemingly flat and you can move in 3 dimensions. It's what physicists call a frame of reference, the perspective you have of the universe and how you see things moving around you. Where you are up and down is your frame of reference is correct for you, but not for the rest of the universe. Around 5 kilometers from you, where the horizon begins, the ground noticeably curves away from you. If you could see through the ground, you would see people from below or sideways, but they don't fall down off the planet because gravity doesn't actually pull them down. Down is an illusion of your reference frame.
To Earth's reference frame, gravity just pulls in. But for humans, there is an up and down, because within our frame of reference, that just makes sense. Which is also why we think that the planet itself has an up and down, north and south, and we made our maps accordingly. But an observer looking at the solar system might disagree. Our maps make sense to us because we are used to them, not because they are correct. Okay, so this is step 1. Your position on what feels like a flat surface but is actually a sphere. But this sphere is always moving, never staying in one position. Earth is orbiting a star, the sun at the center of solar system. While we usually imagine this is pretty orderly, someone looking at us from the outside would see something pretty messy. To see this more clearly, we exaggerate all these movements. This is not to scale, but first of all, our orbit really is an ellipse. So we spend half the year sinking a little bit closer to the sun, speeding up, and half the year rising up a bit and slowing down. And the ellipse itself changes its shape every 100,000 years too. And in another cycle of 112,000 years, the ellipse itself is drifting, which at least creates a beautiful shape.
In the end, we get an orbital path that looks like a wobbly circle with wavy edges, and it gets worse as the moon now starts to mess things up too. As the moon is a pretty massive thing, it pulls on Earth. Both objects orbit their common center of gravity that lies around 4,700 kilometers off to the side of Earth's core. In practice, this means that as the moon orbits Earth, it's jerking Earth around a bit, enough to make it jiggle. Okay, so you are standing on the surface of a rotating planet that is jiggling around the sun in an elliptical orbit that changes a bit every year. But who is to say the Earth is right? From the perspective of the sun, the planet of the solar system is arbitrary. From the perspective of the sun, the planet of the solar system is arbitrary. It's defined as the planet the Earth orbits in because that is convenient for us. In reality, the other planets are just a little bit inclined with respect to our planet. From their point of view, we are the ones with the slightly bent orbit. But this isn't it. Far from it. The solar system as a whole is orbiting the center of the Milky Way galaxy.
If we look at the Milky Way, we can clearly make out a galactic planet in which the solar system orbits the center every 230 million years. But of course, it's not that simple. First of all, the planet of the solar system is not aligned with the planet of galaxy. Nothing really is. Just like the planets in the solar system orbit the sun on their own planes, so to all the stars orbiting the galactic center, the solar system as a whole is tilted about 60 degrees toward the galactic plane. Speeding through space at almost 1 million kilometers per hour, someone in the center of the galaxy would see the orbits of the planet move through space in a helix shape, which you can imagine as a corkscrew motion on the tidal plane of the solar system. Relative to the plane of the galaxy, this orientation in space means that sometimes the planets are sort of in front of the sun as orbits around the galactic core. Let's just look at this for a moment. There is a strange and airy beauty about how our planet and the sun move through space. Do you feel a bit dizzy? It gets worse.
This is still not the whole story because the mass of a galactic disk is constantly pulling on the solar system too. Like a drunk dolphin, we are diving down and shooting up hundreds of light years through the galactic plane 10 times every orbit along arcs thousands of light years long. We haven't mapped this motion out completely as it takes the solar system tens of millions of years to go up and back once, and well, humanity is not that old. Let's look at your relative position again. On a planet tilted towards the sun, jiggled around by the moon in a solar system tilted towards the galactic plane, moving forward in a helical shape, diving up and down through the plane. But where is up in a galaxy? At this point, the frame of reference becomes a bit arbitrary and pointless because of the nature of the universe at this scale.
The Milky Way is part of a galaxy group that appears to be part of the greater structures, like the Laniakea supercluster, which itself is part of the gigantic Pisces-Cetus supercluster complex. And finally, a galactic filament that spans hundreds of millions of light years in all directions and orientations. Someone looking right at us from that far away will only see the end of greatness. Everything appears homogeneous, the same everywhere, just like with empty space when everything looks the same. Who's to say anyone's view is better than anyone else? We have reached the end of our little exercise in cosmic.
That's it for today. Bye for now.